All right, so we are going to go ahead and skip over indicator 26. If we have time toward the end of the mod, we will circle back to it, but if we don't, it's not that big of a deal if we skip it. It's quadratic story problems. So if you stand there and throw a tennis ball up in the air, think about what the tennis ball is going to do. It's going to go up, it's going to go up, it's going to eventually hit a point where it's going to drop and then turn around and fall to the earth. That shape is a quadratic shape, and so we deal with story problems of things like that. Okay, shooting a cannon out of a cannonball out of a cannon, throwing a tennis ball, that kind of thing, squirting a squirt gun. So anyway, if we have time, we'll circle back to it. If we don't, we don't. But we are going to start indicator 27 today. For those of you at home, you're going to want to pause this video here in a minute and sketch these graphs. For those of you in class, I did go ahead and give you a 3-hole punch note, so you don't have to worry about sketching your graphs. You can just put this right in your binder. Okay. All right. So first we're going to, hopefully you've wrote the name on this. Graphing exponential functions is the name of today's lesson. And we're going to talk about what an exponential function is. We're going to kind of compare it to the functions that we have learned so far this year. So let me go up to a blank sheet of paper here. And we're going to kind of talk about all the functions that we've learned this year. So a function is just a fancy term for an equation or an inequality where you've got a couple of unknowns. And it's kind of, I made the example way early in the year about a chocolate factory, like a Hershey Kiss factory. At the beginning of the machine, that's where you put all the raw, all the egg and the chocolate and all that stuff, the sugar, and then it goes through the machine, or in this case, our math function, and it pops out a Hershey Kiss on the other side. Well, our functions, you input an X or your raw ingredients, and it's going to pop out a Y on the other side when it runs through the equation or the inequality. So ones we've dealt with so far this year have been linear. You don't have to put this in your notes. So we've dealt with linear functions where if you put in an X, right, you feed an X into that, you're going to get a Y, and all of you graph them all, it's going to graph as a straight line. Okay, that's a linear function. We have dealt with quadratic functions. What makes this a quadratic function? How can you just look at it and say, oh, that's gonna graph as a quadratic? What do you guys think? Chase? Yeah, it's this right here. It's that your X is squared. Okay, so in the exponent spot, there is a 2. Because that's there, what shape is it going to give us when we graph it? What shape's a quadratic give us? Yes, ma'am. A U shape, yeah, parabola or a U shape. Okay, you don't have to get fancy with the names. U shape works good for me. Today, we're going to talk about exponential functions. And the way you know it's an exponential function is in the exponent spot is where your variable goes. So in the quadratic, we still had an exponent, but the exponent was a 2, and it's always a 2. And our unknown was the base, right? We didn't know the base or the X. Remember, the base is the big number that holds up the exponent. In quadratics, our base was an X and our exponent was a 2. In exponential equations, our base is some number. It can be a fraction, it can be a 2, it can be 1/2. We'll see here today. We'll deal with both. But the exponent that it holds up is your unknown. And the shape that this creates, okay, there's 2 different kinds. There's one that starts off flat and explodes really high, and this is called, I'm just going to abbreviate, exponential growth. And the other one starts off high and shoots down low, and this is called exponential decay. And you might want to jot these 2 down because these 2 you will need to know the difference between exponential growth and exponential decay. And what determines whether or not it's going to be a growth or a decay is your base. For exponential growth, your base is greater than 0 or a whole number. For exponential decay, your base is less than 0 or a fraction, okay? So it's either going to be a whole number That's the greater than 0. Or it's going to be a fraction. And your base that holds up the exponent is what is going to determine whether or not it's exponential growth or decay. And if you think about it, you read left to right, you always read graphs left to right. So going from left to right, the growth starts out low and grows. Reading it left to right, the decay starts out high and comes down. Okay? So just a kind of a silly memory, the exponential graphs, right? There's an x in the exponent and the graph explodes. Okay, a lot of x's in there, but that's kind of how to remember that these tie together. An x in the exponent spot, and the graph is going to explode. Okay? All right, the other thing I want to talk about, and you can put down your pencils for this part, you don't have to write this down, is just as a review. We have talked about, I just now wrote that up there. Another way to write that is this. Remember, f of x is just a fancy y. It's just a different way to write it. So if you see it written like this right here, if it makes it easier in your brain to process it, rewrite it like this. X or f of x is just a fancy y. And the f is just a name, right? If I said, Will, come here, Will would know I was talking to him. If I said, hey, student, come here, who am I talking to? Hey, student, come up here and get this paper. Who am I talking to? You don't know, right? Because I just said, hey, student. But if I said your name, right, Houston or Camden, put your phone away, or Will, come up here and pass out papers and quit playing games, whatever, all right? I'm sorry, I'm picking on you, Will. We're done. I won't pick on you anymore. The f of x, the f part is just its name. So you could say f of x, you could have a g of x, you could have an h of x. The only reason, it's just like having a name. And the only reason you would have them is if I wanted to compare two of them and I said, tell me what g of x says, you could look up there and see which one is a g, right? Did I lose you? No, you had a confused look on your face. The g of x, f of x, h of x, whatever the number is, or whatever the letter is in front of it, it's just its name. And all of them are just simply a fancy y. You could rewrite g of x as y equals, okay? And that part is just a little bit of a review because you are going to see it written a lot of times as f of x equals. And that's the same with linear, quadratic, exponential. You can replace that y with a fancy y and call it f of x, g of x, h of x, whatever, t of x. All right, now let's get to our examples. So your first example there's a very specific way I want these done. And with every single one of them, you are going to start out with an XY table or a T table. Okay? Anytime you have an equation that has X's and Y's, you can pick X's, plug them into the equation, run them through the machine, right, or the function, and it's going to spit out a corresponding Y. That X and Y go together to make a coordinate point that you graph on the graph. Now, you're always going to start out with the same basic 5 every single time. And when you write it, notice I'm going to not write it all the way at the top. I'll show you what I mean. I'm going to drop down a little bit. I'm going to leave space for something. And then I'm going to write -2, -1, 0, 1, and 2. Notice I left space at the top. Because once you graph the basic 5, if you can't get a good feel for where your head or your tail is going, sometimes you need to go in and fill in a top or bottom point to give yourself a little extra clarity. Okay? So you always start with the basic 5. Same basic 5 every time. -2, -1, 0, 1, and 2. Now you have to just take your equation, which is right here, or your function, and you have to work it 5 different times. And each time where you see an X, you're going to plug in one of your X's that you put in the T-chart. So the first time we work it, we're going to use the -2 in place of X. So Y equals 2 raised to the -2. We put a -2 up in that exponent spot because that's where the X was. And we're replacing the X in the equation with our X's. Now, this is where your knowledge from a couple indicators ago comes in. How do I deal with a negative exponent? I have to flip it first. So I'm going to go 1 over 2 raised to the 2. Now I've gotten rid of that negative exponent. It becomes a fraction. That's fine. 1 over 2 squared is 4. So when x is -2, y is 1/4. And I come over to my t-chart and I fill in my y value for that x. When I'm done, I'm going to have 5 coordinate points that I can graph. Now I do the same thing again, only this time y equals 2 raised to the -1. I put a -1 in that x spot. Again, I have to deal with that -1 by flipping it. And anything raised to the first power is just itself. So when I plug a -1 into the x spot, my y value is 1/2. Now I'm going to work it again. Y equals 2 raised to the 0. What is anything raised to the 0 power? A 1. So in my t-chart, I'm going to put a 1 there. Some of these are super easy mathematically. Some of them take a little bit more mental exercise here. So my next one, y equals 2 raised to the 1. Super simple. What's anything raised to the 1? It's itself. So when x is 1, y is 2. And then work it one more time, raised to the second power, which is 4. Now, before you decide whether or not this is sufficient, you have to graph these 5 points. So think about this, right? Each one of these is a coordinate, right? -2 and 1/4, that's an x and a y. So I'm going to go backwards -2 and up 1/4. Now I can blow up my screen. You can't really blow up your paper, but if you blow this up really big, okay, if I go backwards -2, that puts me right here. Now I want to go up 1/4. Well, it's a little difficult to go up as far as your fractions are concerned, but if you think about it, this is 1/2, so about here would be 1/4. Now, as your fractions get tinier and tinier, you just got to put it right above the line. It's just going to be as close to 0 as you can get it because your fractions are going to get tiny sometimes. You might have a 1/64. Well, 1/64 of one of these little bitty blocks. Are you going to be able to actually graph that? No, a computer can, but you can't. So just put it right above the line. Okay? All right. Our next point was -1, 1/2. So I'm going to go backwards -1, up 1/2. So that's going to be about right there between 0 and 1. Then our next point was 0, 1. So that's there. Our next point was 1, 2. Is that right? And then 2, 4. Now, these points, it's a little hard to see what's going on here. Okay? You really can't tell your head and your tail. Now your tail, you've already got 2 fractions. That's all you ever need, okay? If you've got at least 2 fractions in your table, you're good. You can figure out your tail. So my tail is going to swoop down this way, and it's just going to run right along here, and it's going to forever and ever get closer and closer to 0 without ever touching it. You can't do that with the human eye, but we can do it on Desmos, and I can show you tomorrow. As far as our head, let's add one more point in here because we really need to get an idea of where our head's going. So I'm going to do one more, 2 raised to the 3, which is 8. Okay, that gives me a better idea that how high I'm going. And then if you really wanted to, but you don't have to, you could even do 4 because 2 raised to the 4th is 16. And that one would be way up here. You can see how quickly these jump once you start growing, you're going to grow really fast. Once you start shrinking, your fractions are just going to get itty bitty bitty tiny, okay? So now we have a good idea what our head's doing, and there we go. We've got a good exponential. Okay? You could have even skipped 3 and gone straight to 4 if you wanted to get a good idea without doing 2 extra points. Sometimes though, if you go too high, you're off the graph. Like, let's say I would skip 3 and 4 and I'd go right to 5. What's 2 to the 5th power? Yeah, that's off my graph. So you may have to back it down a little bit if you get off your graph. Okay? All right, let's take a look at number 2. Everybody good with this one? Because I'm going to have to erase this to have room. These really do take up a lot of room. If you ever, on your homework assignment, need a blank sheet of paper for your work, you don't even have to ask me. Just do it and staple it to it. These take up a lot of space, okay? And I would rather you take up space than try to do some of these in your head, because last hour I had everybody trying to do it in their head and they were getting wrong answers and couldn't figure out why. And I can't look in their head and see where they went wrong in their math. So write it down on paper like I do it. All right. All right. I'm going to start out with my basic -2, -1, 0, 1, and 2. Those are my starters. Leave a space above in case I need to try a -3 or a -4. Leave a space below in case I need to add some. Now, before we decide, let's work these 5 problems. So we've got y equals 1/4 raised to the -2. Well, I have a negative exponent, so what does my fraction become? How do I deal with that negative exponent? I flip it and my 1/4 becomes 4. My exponent is still a 2. It's just not a negative anymore. And 4 squared is 16. So in my t-chart, when x is -2, y is 16. I'm feeding ingredients into my function, which are my x's, and I'm popping out y's that go with them. Okay, I'm going to work it again. Only this time in the exponent spot, I'm going to put a -1. Again, I have a negative exponent, so I have to flip it. A fraction becomes a whole number. Raised to the 1, it's just a 4. So when x is -1, y is 4. I'm going to work it again, only it's to the 0 power. What's anything to the 0 power? 1. Doesn't matter if it's a fraction or a whole number. Anything to the 0 power is 1. Now I'm going to apply my 1 as my exponent. Well, anything to the 1 power is just itself. So when you plug a 1 in, you get 1/4. And when you plug a 2 into the exponent spot, you square both top and bottom, but 1 squared just stays a 1. 2 squared is 4. So you, oops, no. What did I do wrong? I put 1/2. Thank you. I knew something was off because I couldn't get 1/4 twice. You can't have the same y twice. So if you get the same y twice, you've messed up. There we go. What's 4 squared? 16. 1/16. All right. So now I've got 5 points. Let's plot those first and then see if I need to fill in the blanks. But I can tell you right now, having 2 fractions, your tail's going to be fine as long as you have 2 fractions. And then we'll look and see if our head is evident where it goes. So -2, 16. That's way up here. -1, 4. You can see how quickly that drops. Exponential means quickly. 0, 1. That's here. Now, again, I'm going to blow this up to show you, but just do the best you can. When you go over to the 1 spot on the x, and then you're supposed to go up 1/4, okay, that's just going to be kind of right there, right? Just right on top of the line. And now when you go over to the 2 spot, which is here, you're supposed to do 1/16 of that little bitty box. You can't. Just put a point right above the 0 line, and that's good enough. Do my 1/4 and my 1/16 look a lot alike? They absolutely do. There's nothing you can do about that on your paper, okay? So my tail is fine because I had 2 fractions, and I can see that it's just going to skirt right along that 0. My head's perfect. I can see I'm going to shoot way up here. I don't need to fill anything else in. The 5 basic ones were perfect. Sometimes they'll be enough. Sometimes they won't. Just depends on once you graph them if you get a good idea. Any questions on the first 2? All right, for the last 2, it doesn't really do any, you don't really do it different. It's just your equations get a little bit more intricate. So we still start off with our t-chart. We still start off with -2, -1, 0, 1, and 2. Now, PEMDAS matters very much here, all right? So it's y equals 4 times 2 raised to the x. Well, here I'm going to put a -2 in for the x. Don't mess with the 4 times right now. That's multiplication. You always do exponents first. So 4 times, how do I deal with that -2? I flip it, and I still have that exponent, so it becomes 4 times 1/2 squared is 4. Now I'm ready for multiplication. 4 times 1/4, those cancel out, and I get 1. So it's a little bit more math when there's a multiplication added in there. And you have to do it in the right order. If you take 4 times 2 first and then get 8, and then take 8 to the second power, negative second power, you're going to get 1 over 64. You're going to get the wrong answer if you don't do it in the right order. All right, now we're going to do 4 times 2 raised to the negative 1. I have to deal with that negative first, so 4 times, flip it over, and when I apply the 1 exponent, it just stays 1/2. So what's 1/2 of 4? 2, so I can plug a 2 in here. Now 4 times 2 to the 0, because I'm plugging a 0 in for the exponent. Don't do the multiplication yet. 4 times, what's 2 to the 0? 1. If you do the multiplication first, and you do 4 times 2 is 8, and then 8 to the 0 power is a 1, you're going to get the wrong answer. You've got to make sure and do PEMDAS in the right order. All right, 4 times 2 raised to the 1. Well, 2 raised to the 1 is simply 2. 4 times 2 is 8. Those are nice and easy. 4 times 2 squared is 4 times 4, which equals 16. Again, notice they start out really small and they get big really, really fast. Now, do I have a fraction here? So I can already tell you you're going to need to add at the top because I don't have a fraction, and you need at least one fraction. Preferably 2, but I'll be happy with 1. I'm going to go ahead and skip to negative 4 because I want to get a good idea where my tail's heading. Okay, and I can do negative 3 and negative 4, but why do double the work? So I'm going to come down here, 4 times 2, and now I'm going to put to the negative 4. 4 times, I got to deal with that negative by flipping it, so it becomes 1 over 2 to the 4. And that is 4 times, what's 2 to the 4th power? So it's 1 over 16, which equals 1/4. Now I have a fraction. Now I'm happy there. Now I'm going to get a good idea what my tail's doing. You need at least one fraction. Now, if I were to do this and I were to gotten a whole number here, that would have been a big red flag that I did some math wrong, because you will never come back around and get another y that matches. These are not like quadratics where you have any reflecting points. You have no reflecting points. So your y's will never, ever be the same. So if you get an 8 on top and an 8 on bottom when you're doing the negatives and the positives, one of them you forgot to flip. Okay? All right, I've got plenty of points now, so I'm going to go over to negative 4 and graph 1/4. Again, that's just going to be right above the 0. It's the best I can do. I'm trying to make this bigger here. So I've graphed my negative 4 point. I skipped negative 3, so now I'm going to go to negative 2, 1. That was that point. Negative 1, 2, 0, 4, 1, 8. You can see I'm starting to get bigger exponentially. And then 2 goes way up to 16. Head's great because it's almost to the top of your graph. Can't do any better than that. And because I added that fraction, my tail comes right down here and runs right along the 0. Any questions on that one? This right here, I'm going to circle it because I'm going to erase it here in a second anyway. All of this work right here, okay? I know it's very tempting to do it in your head. Please write it out like I do. I know it takes an extra minute to do it, but again, if you've got something wrong and you come up and say, I don't know what I did wrong, I can't look in your brain and see the math you did in your head. I can look at your paper and say, oh, you forgot to flip it, or you forgot to multiply it times 2, or you did your multiplication before you did your exponents or whatever. So don't shortcut it. It's not going to do you any good. It's just going to end up causing you to miss things you shouldn't miss. All right, last one. Again, not harder, just a little more time consuming because the equation is a little bit more intricate, okay? So I start off with my xy and negative 2, negative 1, 0, 1, and 2. Leave room for top and bottom in case I need it. All right, so I've got 5 times 1/2 raised to the negative 2. That's my first one. It's y equals 5 times 1/2 raised to the x. My first x is negative 2. Leave that 5 alone for right now and just flip that fraction over. So 1 over 2 becomes a whole number. still to the second power because you don't lose your power, you just lose your negative. 5 times 2 to the second power is 4. 5 times 4 is 20. So I can fill in my 20 there. Now I'm going to do 5 times 1/2 to the negative 1. Same thing, 5 times, leave that alone. 1/2 to the negative 1 becomes 2 to the 1, which is just 2. 5 times 2 is 10. 5 times 1/2 to the 0. Leave that 5 times alone. What's 1/2 to the 0? 1. 5 times 1 is 5. 5 times 1/2 to the 1. Well, 1/2 to the 1 is just 1/2. And then 5 times 1/2, half of 5 is 2.5. And then lastly, 5 times 1/2 to the 2. I'm going to leave that 5 times alone right now. 1/2 squared is 1/4. And if I were you, I would first multiply across the top. So 5 times 1 is 5 over 4, but 5/4 is kind of a hard number to graph. So convert it to a mixed. So that would be 1 1/4. And oops, I forgot to fill in my t-chart with my 1 value. So when I put 1 in, I got 2.5. When I put 2 in, I got 1 1/4. All right, let's graph these 5 and see what we get. So negative 220, I can already tell you have a good head, right? Negative 220, that's way up there. I can already tell what the head of my graph is doing. Negative 110 drops really quickly. 0.5 drops even more. There's that. Let's see, 1 2.5. So 1 2.5 is kind of right there between that 2 and 3. If you need to blow it up a little bit to see that. Right, there's the 2, there's the 3, so 2.5 would be halfway in between them. And then 2 1 1/4. So 1 1/4 is just barely over the 1 mark. Now, if you're not sure, your head is definitely completely completed here because it goes off your graph, so that's good stuff. Your tail is a little ambiguous here, so if you need more of a tail, where would my tail be here? It wouldn't be the negatives in this case. Because this is decay, my tail would be down here. So I'm going to pick a 4. So I'm going to add one more. 5 times 1/2 to the 4th is 5 times. Well, when you take 1 to the 4th, it's still 1. No matter how many times you multiply 1 by itself, it stays 1. And then 2 to the 4th power is what? 16? Is that right? Somebody check me here. And then when I multiply across the top, I get 5. And when I multiply across the bottom, I get 16. So I can fill in 5/16 here. So again, that's not quite 1. Or it's not even close to 1. It's not even close to a half. So at 4, I'm all the way down here. Now I've got a good idea where my tail's running. It's running right down along there. On all of today's, your tail is always going to run across that 0. In tomorrow's, you'll see your tail changes a little bit. But for today's anyway. All right, any questions on that? All right, for those of you at home, go ahead and click load on the assignment. Show all of your work just like I did here in Kami. On Kami, if you need to add an extra page, you can scroll to the bottom of your page and there's a plus button. Click that and you can add a page to your Kami so that you can show more work if you need to. Email me if you have any questions.